Hi everyone, it's Miss H, and we're going to be starting our new unit today on work, power, and simple machines. So today we're going to be talking about work. Our next video will be on power, and then our final one will be on simple machines. So what is work? What is work? Okay. Work is the transfer of energy. We can accomplish this transfer of energy by applying a force to move an object through a distance. Work is only done when the force is done in the same direction as the motion of the object. So if I'm pushing to the left, but the object is moving up, I'm not doing any work on the object because the force that I'm applying is not actually moving the object. So in order for work to be done, the force, the direction of the motion have to be the same. So work is the transfer of energy, and so that is accomplished through moving an object over a distance by applying a force to it in the same direction that it's moving. The variable for work is a capital W. The unit for work is the joule. It's named after a person, so we use a capital J. A joule is the equivalent of 1 Newton meter. And the formula for work is force times distance. So if we put this into that helpful little triangle we talked about before, okay, we're going to try to keep our multiplied values together. So force and distance are going to be multiplied together in the bottom, and work goes in the top. So if I cover up my D, if I cover up my W rather, I get F times D back. If I cover up my F, I get W divided by D, and if I cover up my D, I get W divided by F. So let's take a look at some example problems. How much work is done when a 50 Newton force moves an object 2 meters? So the first step we want to do is identify what information we're given and what we're being asked to solve for. So we're given 50 newtons is a force, we're given 2 meters is a distance, and we're asked to solve for work. So we're solving for work. We're provided with a force of 50 newtons and a distance of 2 meters. So then step 2, I'm going to write my formula. W equals F times D. Step 3, I'm going to plug my numbers in. 50 newtons times 2 meters. And then step 4, I'm going to solve 50 times 2 gives me 100 joules. Joules is my final answer. So 100 joules of work. Let's take a look at another example. How much force is needed to move an object 10 meters by doing 300 joules of work? So first we're going to identify 10 meters is a distance, 300 joules is work, and we're asked to solve for force. Step 2, I'm going to write my formula. So in order to figure out what my formula is going to be, I'm going to use my triangle. And so since I'm solving for F, I get W over D. Step 3, I'm going to plug my numbers in. 300 joules over 10 meters. And then 300 divided by 10, step 4, I'm going to solve. That gives me 30 newtons. So 30 newtons of force are used to move an object 10 meters by doing 300 joules of work. Example number 3. How far will an object move if 25 newtons of force are applied when 500 joules of work are done? So step 1, we're going to identify 25 newtons is a force, 500 joules is work, and how far means I'm solving for distance. So step 2, I'm going to need to write my formula. In order to do that, I'm going to create my triangle here so that I can figure out what my formula is going to be. So D equals W over F. So that's going to be 500 joules over 25 newtons. And if I type that into the calculator, 500 divided by 25 gives me 20 meters. So 20 meters is the distance that this object is going to move. Let's try a more complicated example now. A force is used to raise a 20-kilogram object 2 meters. How much work is done? So let's start with our identify part. 20 kilograms is a mass. 2 meters is a distance, and it wants to know how much work is done. Well, we know that work is force times distance, but I'm not given a force, so I need to think back to my previous unit when I learned about forces and weight to figure out how to solve this problem. So the weight of an object, remember, is acceleration. So F sub g, which is weight, is mass times acceleration due to gravity. So I can substitute mg in for my F and then multiply by d. Remember that on Earth, g is 9.8 meters per second squared, or meters per second. So that gives me 20 kilograms times 9.8 meters per second squared times 2 meters. Okay, and then I put all of that into the calculator. What I end up with is a W of 392 joules. Okay, and again, you can look at your units there by saying kilogram meter per second squared is a newton, and a newton meter is a joule. So that helps you work out all of your units there. All right, let's take a look at one more problem. A student holds two 2-kilogram books 1.5 meters above the floor. How much work does the student do? So we have two 2-kilogram books, means that we have a mass of 4 kilograms. Okay, they're being held 1.5 meters above the floor, so the distance above the floor is 1.5 meters, but that's not actually the same as the distance that it's being moved. Okay. And we want to know how much work is done. So this is not the distance. This is not distance, okay, because that's just telling you where it's currently at. It's not telling you where it moved. Okay, so with this question, things are a little bit different because the student is holding the books. So if you are holding something in place, you are not moving it. So if you are not moving something, then D equals 0 meters. So when you're not moving something, D is 0 meters. Well, W equals FD. Anytime you multiply by 0, you end up with 0. So if you are holding something in place, you are not doing any work. Now, your arms are going to get tired from holding those books, but you're not actually doing any work on those books because you're not moving them. So that's an important thing to remember with work. Again, the distance has to be something other than 0. Okay, and then also your motion, the force applied has to be in the same direction that the object is moving. If it's not, then no work is done. So that gives you a good overview of work.